Dr. Vasant Khisty has worked for almost more than 33 years in manufacturing, engineering, business development, and he has worked as a president with Indian and multinational companies. His core skills are forging technology and business development for driveline systems and gearboxes. His topic is very interesting, which at least I am hearing for the first time. His topic is IOT, which is Internet of Things. This topic is role of IOT in improving global competitiveness for forging industry. Welcome, Dr. Khisty.
Thank you very much. First of all, I would like to thank Mr. Kulkarni for organizing such a seminar. And I have colleagues, and senior colleagues and respected colleagues from different companies that I have worked with. So I start this presentation with due respect to Mr. Mathur, who is our quality guru, and he taught us quality. When I was a young boy, I worked with him. So, okay. Now, Sami Consulting, I will not be advertising more about it. I will be straight going to the topic. We are into consulting business of technology. Okay. So, role of IoT in improving global competitiveness for forging industry. Now, IoT is a buzzword with every WebEx, every alternate WebEx is on IoT. I was flying from Bangalore, and then somebody was sitting next to me, and I was discussing with him about what he is doing. So he said he is into IoT. So that intrigued me, and I went into websites and saw what IoT was. Then I thought how I can implement this IoT. I am a novice in this technology. I also don't know what IP address means. So please do not ask me anything about the Internet of Things. But I am just expressing my imagination as to how Internet of Things can be used in forging technology. Okay, what is IoT? IoT in short term is Internet of Things, and which every gadget has a sensor, and the sensor is connected to gadgets all around the world. So if I imagine, the best example of IoT is a human body. See, we have 5 sensors, means we have 5 sensors. Every cell of our body is a sensor which can sense, and there is a cloud up here in the head which receives all the information and gives instruction to other parts of the body. This is a very simple example of IoT. If there is a mosquito over here, your hair can sense that mosquito, give a signal, and your hand can hit and kill the mosquito. So it is without any intervention of your conscious mind that you are taking an action. So in IoT there are 2 things. One is machine talking to the machine, and one is machine talking to the human, and the human intervention to correct the thing. So this is a very simple example of what is IoT, and the best IoT is a human body. So every gadget has an IP address, and it is connected through internet. Now, what they say in future, 100 million people. Connected applications will be there, 1 trillion connected devices, and 8.5 billion people connected by 2040. This is the scope. So I thought, why not forging technology also try it this way? Okay, need of the forging industry. See, we need to be globally competitive, and that is what this forum is for. And we have all the tricks of the trade. Now the biggest thing that we will have to be further become competitive is how do we reduce our cost further. So our objectives are to match the global quality standard, to be connected to customer in real time, to eliminate every possible waste. Waste is such a thing that our sensitiveness to the waste has to increase now, and to the extent that a body movement of an operator is also a waste. Okay. To achieve, we are going for high cost capital equipment. We have to achieve higher ROI. We have to have flexibility, optimize tool life, real-time maintenance, reduce time to market, because we have to review several samples, and our friend showed simulation software which helps us to achieve that. Reduce inventory, remote access to the data. If Mr. Mathur, my friend, is sitting in America and he is finding some problem in his machine, he can stop his machine sitting in USA while he is in a meeting. Okay? Real-time quality management and real-time yield management. So let's see, what is IoT? Say it has device sensors like some of the characteristics like billet temperature, cut weight, die temperature. So there are sensors for each of them. They are put on a breadboard, and then there are gateways like we have the nervous system and the blood flow. These are the gateways, and this Ethernet through Ethernet or Wi-Fi. There are many other technologies. It will route it to the router, to the cloud, and it comes to the front end client, mobile phone or this laptop or any handheld device, and you can take an action. This is one way. And then it goes the other way also in order to take autonomous action. So the architecture, this is a much better figure here, is you have sensors and actuators and IOT devices and IOT gateway, because you need to give a gateway. There are billions of data that will be generated while you are forging. The right kind of data needs to reach the cloud. And then you have a lot of analysis tools over here, data storage tools, and it gives you output through SMS, push, email, etc., etc. And you can take the actions sitting at a remote place. So, like you have a machine over here, you have sensors for air quality, temperature of a compressor or the quality of the air coming out. Through the IoT it will go to a cloud, and through cloud it will go to a maintenance man, and he will take certain action. Or the machine might come to the machine, and machine will take a certain action. So, what are the major parts of IoT? Sensors, activity sensors. We are in this room. Now we have 100 people scattered. If everybody comes in the front, why do we need the light over there? So there is no activity there. The activity sensor will sense and off the light. This is a saving. And see, imagine we have got 10 machines. For getting the best power factor, you need to know the sequencing of the machine. And when machines start in sequencing, your power factor improves. So these intelligence are given by the sensor. Then these are called nodes. Then there are gateways. These are gateways through which these information the sensor takes and passes on to the cloud. Okay, these are hardware and software encrypted in it. And this communication flow can also happen in the reverse manner. I will not go to those parts where I am not strong at. So let me imagine what are the applications in forging. So you have got a laboratory, stockyard, cutting, heating, forging, trimming, heat treatment, shot blasting, inspection and all that. Then this all is under engineering, quality assurance, maintenance, PPC, logistics, sales. These are the service activities which support this activity. So these are all the different kinds of communication that will be taking place through the shop floor. And these are all be designed in a certain manner where forging and trimming will be talking to the heat treatment will talk into the shot blasting, forging and trimming will talk to the heating will talk to the cutting will talk to the die shop. So all these interactions will be developed in order to achieve reduction in waste, eliminate waste. Let us take some examples. Now, we all are going for flashless forging where we cannot afford to have flash. And in order to have flashless forging, you need to locate. I am just giving some examples, there can be many. So you need to locate a particular preform into the die exactly where it is supposed to be. Otherwise, you will get a fin on one side and underfill on the other side. There is no scope for any mistake. So here you have got sensors in which you can check the diameter in real time. You don't need an operator to take out the piece and cool it and then check it. Real-time sensors, and based on this, if they are finding that the cut weight is not okay or the billet temperature is not okay, the diameter is increasing by 1 mm or reduced by 1 mm, it should be taking an automatic action over here by giving information to the table down to take it up or down in real time. Now see, this activity, if you want to do manually, you will waste at least an hour. So the sensor will give information to the servo drive motor over here, and then there is a wedge which will go up and down. These nuts are hydraulic nuts which will open and close. So imagine if you are getting, say, undersize or oversize or something, how much time? It might take an hour for first to cool the job, inspect the job, and after inspecting the job, you will then go and stop the machine. The whole machine will stop. 10-15 induction hardened pieces, induction heated pieces will come on the shop floor. Then you will search for the spanner, and then after you get the right spanner, there is a waste of time which can be eliminated if there is an intelligence in real time to do the corrective action without human intervention. This is one example. So let's say cut weight control. Now we see we have die lives like say 5000. If we have a crankshaft which requires say 50 kg of weight, that 50 kg of weight is cut for the last piece to get filled. Okay, it is not cut for the first piece to get filled. And if you say a crankshaft volume, sir, what would be the volume difference in the die life? Must be 5-6 kg, 7 kg in a 70-80 kg crankshaft. So you need to cut your pieces incrementally so that your average cut weight of the whole die life will get reduced. By putting an excess weight initially, you are also spoiling the die because you are pushing the extra material out of it. So if we have a system in which there are sensors and these sensors give information to the billet sharing machine that the weight of the forging is this much, you need to cut this much, and the shearing machine is online and cutting incrementally as the die wears out, the volume of the cut billet is increasing. This you can't do manually, but if there is an intelligent system built in or embedded inside, you can do it without a human intervention. You will save raw material, you will save time, and you will increase your die life. So these are some imaginations like real-time maintenance. Now there are two ways of it. You are having TPM in your company. You have decided to change the filter at 1500 hours for a compressor say. After 1500 hours, you get an alarm over here. Okay. Apart from this, this maintenance man will go and change the filter, etc., or he can plan. Or if he is finding that after 1500 hours it is not getting spoiled, he can, in his TPM schedule, he can change it to 2000 hours. Okay. But when the filter is reaching 1500, the store department will get the information. The machine guy who designed the machine also gets the information in real time as to how his machine is behaving, and he can modify his machine. Now quality management. Now quality management is like you get a forging, then you cool it. After cooling, you check. Okay, you can also check certain parameters in hot also. But by the time you are spoiling 50 pieces, 30 pieces, 20 pieces. Imagine a ring gauge. One ring gauge costs you 5 lakh, 6 lakh rupees. 5 meter ring gauge, 3 meter ring gauge. So if you have a real-time inspection going on, there is an SPC chart. Based on this data, all the information goes to the cloud. Corrective actions are taking online over here without human intervention. The thickness is coming oversized, the bed goes up, the temperature goes up, whatever factor affects over here. And you have an SPC, it goes to the cloud, and you have a big data of analysis that you can do. And your customer can see his products being forged and say, oh, they are forging oversized right now over here. Because the customer will be seamlessly integrated with the supplier as far as engineering is concerned, quality is concerned. And you can have a very good traceability in terms of this kind of visibility available to all the partners. Now quality management, one more example. Now you have different scanners who can scan, or it's like a imaging, like our face recognition software or something, which can scan. In this simulation you can see that the piece is coming underfill over here. Now this underfill can be scanned and it can have an intelligence to increase the cut weight or increase the temperature or reduce the gap. So these sensors will check the image and give information to different partners, and you can have a traceability, and you can also then link it to your engineer documents like PPAP, FMEA and all those stuff. So based on this big data you can do your re-engineering. Intelligent bolsters. You can design bolsters which are intelligent, like die life we have been talking, and my friend gave a lecture on special lubricants. Now if you see that thermal shocks is one of the reasons for reducing the die life, and thermal shock depends on the time, on the surface temperature of the die and the quenching of the die because of the localized lubrication. Now here if we can sense that the die temperature is increasing to 300, 400, 500, certain plugs become red hot, it should give information to the coolant lubrication tank, which can increase its time of lubrication or the mist that is being formed, and it will automatically do it instead of stopping the machine and changing the settings over here. Here you can have intelligent bolsters in which you can correct the mismatches. If you are seeing that there is a mismatch, this cylinder, hydraulic cylinder will get loosened up, this will get loosened up, it will tighten up somewhere over here and it will correct it automatically. But if you want to correct this mismatch manually, you might take an hour to do that depending on the size of the press. Okay. So press deflection. Now press deflection is a very major thing, like especially in presses when you are forging crankshaft, when you are touching die to die but the thickness comes 5 to 6 millimeters in the flat thickness because the frame deflects, the bed deflects. So these kind of information, if we have got a strain gauge and a load cell, these informations can be captured by the machine manufacturer also. And there is one more thing, that this real-time data, we have simulation software and it is inevitable that it is now sort of a mandatory that we should have simulation software in every company. Because here you will be, without using this, you are wasting your productive time on the machine. The machine is supposed to make forgings, not to take trials. It is for commercial production because you need to get your ROI on the big capital investment of 30 to 40 crores. But these data, in order to customize the particular simulation software for a particular company, okay, you get a general simulation software. But if you want to customize for say 15 forging machines in say Bharat Forge, what is the press deflection? This data can be captured into the simulation software and the simulation software can be calibrated and customized for your machinery. So press bearing life sensor, you get now bearings. Now one of the things is the bearing gets hot. You come to know if the bearing is broken, the maintenance man comes to know that the bearing is broken. But here you get bearings with sensors which will sense the vibration, the temperature and give information to the maintenance guy, okay, or increase the lubrication depending on the temperature. It has to be done automatically without human intervention. So wastages in forging, there are several wastages and IOT can help us by removing those wastages like die setup times, die run rationalization, die corrective action, breakdown maintenance, inspection, tool management, rework, line balancing, trim press and forging presses, online heat treatment balancing, space management, development time. These wastages need to be eliminated. So if you see some of the variables like cut weight, forging temperature, die temperature, lubrication, machine energy, ejection speed, rhythm and cycle time, operator skill, die wear. So these can be all measured by sensor, sent to the cloud, data can be analyzed in long term, the corrective actions can be taken. Now there are various partners now involved in these kind of activities and sensors made in China to software made in Germany and gateways made and various partners like Cisco and IBM's having different cloud. So in order to, like ISO 9000 was brought in to standardize the terminologies of quality, so everybody understand that word. So similarly there are 4 industry regulations. One is water and steam, second was electrical, third was electronics and IT system. Now this is called cyber physical revolution. Okay, so Industry 4 is coming out and is being implemented in Germany, which is trying to standardize various aspects of the hardware and software and the technology. So there is a common understanding. Okay. Now there are 4 principles of Industry 4: interoperability, that anything can work with anything. Then information transparency. Technical assistance means it should be able to give you intelligent feedback or intelligent solutions. And decentralization of decisions, that not everything will go through the boss. It has to take action on itself. So a smart factory, A4 shop in future would be looking like this. So the kind of people you will be requiring is like my friends who can digitize and my friends who can mechanize or maintain these kind of things in real time. Human body will not be required to lift a component of forge. So this is the kind of a smart factory that will be developed. So there will be a paradigm shift. Now in order, currently in our organization you have got CNC, then PAC, PLC, then you have SCADA, MES, ERP. So these are built over each other. But with cloud data, anything can interact with anything. You don't need these foundations to to finally get your data route through ERP over here. And IoT can really play a major part in automatic corrections, data management and analysis, and integrating all the partners in real time. So I am looking for partners who can partner with me. I have ideas, concepts, I don't know IoT architecture, and if somebody is willing to join hands with me, I would like to work in this area. So I see a big potential. So I am ready for questions. Having worked in Photoshop, my ears are.
Any idea where we can get this cloud data storage through cloud?
You see, there are many people like Cisco, IBM, many people who provide you these services. You go on the internet, you will get this information. There are 2-3 companies which are working now in India, like Chipmunk Technologies, Exalta, who are working with Hero, Honda, where they are doing right now on the real-time maintenance, TPM technology. So they develop the whole architecture of these technologies and also provide the cloud space. So they buy the cloud space for themselves. But you can buy, even on this mobile, these youngsters will tell you how to get a cloud space to put your pictures, photos, files. So the cloud space are available for free also and for rental also. Maybe your son or daughter may know it better than me.
I don't think that will really suffice because I am talking about incidents where you need to store some battery data. Nowadays the requirement has come that you need to store your data for 15 years. Now this what you call that hard drive, portable hard drive, they are becoming excessively unreliable.
Yes.
Keep one copy, 2 copies, and people are looking for some party.
The IBM, Cisco, these are the 2 names, but there are many people who are into cloud service. Amazon, there are many people. It's a very common thing now to get this out. But since I am not acquainted with the architecture of these technologies, I don't have to answer. But there are people who are giving trainings also. Training programs can be organized in IoT.
Very good presentation. But will it work for small scale industry?
Yeah, it can work for you. Your homes are now IoT enabled.
Yes.
Your refrigerator, your oven, your car is totally IoT enabled now. So why not for the small scale industry?
What could be the cost for a medium scale food shop?
It has to be worked out. It can be as cheap as 500 rupees to $1 million depending on the requirement. These are very simple mobile based apps. The apps is an example of your IoT.
Has it been implemented anywhere in India?
In India, no, but these German companies have their machines with built-in intelligence. And I am told that the Koreans are coming out with these equipment where they can check the sensor, the pancake size, and calibrate the diet accordingly.
Any more questions from anybody? If nobody has, then I have a question, Dr. Khisty. First of all, I would like to congratulate you because you have been too modest in introducing yourself, but you do not know anything about IT and cloud. I think you know a lot. So your whole presentation was based on IT and clouds. I have just one thing in mind. Now that you have said that it is not so popularized, not so being followed in India, so I think the question of finding out solutions for any problem still have to be worked out when somebody works on this, as you said that you are looking for somebody to do this. Is it possible from your study that can IoT be applied in restricted processes without any major change in the equipment?
If you want your machine to be intelligent, you will have to make certain changes in the machine. So if you want your this thing, the bolster to go up and down, you need to actuate your wedges below hydraulically.
Okay, and then hydraulic can be actuated by a sensor. So minor modifications would be required. Mechanical nuts have to be changed with hydraulic nuts, which can open and close in real time. So some modification would be required for equipment depending on the extent to what you want to. Like suppose for a compressor, if you want on your mobile, the blinker saying that now the piston ring has to be changed, the piston has to be changed, the oil temperature is going up, the humidity of air, it will not require major changes. It will be just installation of sensor and it will come on your tab, and then you take a correct. You go to a hotel now, they come with a tablet and put the menu and the cook gets the information. That's a very simple example. It doesn't need expense.
Yeah, that's a simpler part of it, but would you agree that this kind of an idea has come from, this idea has already been adopted in the real estate industry where you can switch on your ACs or switch on your ovens sitting in the car, and I think this idea has come.
Yeah, it
Already been
in healthcare, in domestic, in logistics, all these ideas are completely implemented right now. And even in manufacturing, if you go to Volkswagen shop floor or any other new automated line, these are all robots are talking to each other and intelligent robots. So this is now sort of becoming mandatory in order to be competitive.
I think this was an excellent presentation, and we have, I think none of us have ever seen this kind of a thought even coming to our minds that you can operate your forging equipment and you can solve your problems sitting at home, and you can get all the data in hand on your mobile or in your at your desk somewhere. So thank you very much, Dr. Khisty, for the very